The Knapsack problem, or named the handbag problem, is just one problem that tries to solve an optimization problem. So it's only one example of a larger category of problems named optimization problems. In optimization problems, we try to optimize for a target. For example, in the Knapsack problem, we try to optimize the number and the value of items that a thief can put inside his handbag while he is stealing the stuff from your house. So we basically try to optimize for the value of the things, and we have limitations on the number or the weight of the things. Additional examples of optimization problems would be that, for example, you try to optimize for the number of working hours that you have per day to maximize them, while you want to take into account the meetings that you have during the day. Or if you are on a low-carb diet, then you want to optimize for the minimal amount with the threshold of the carbohydrates that you consume per day, given that you basically need some amount of calories per day. Or if you want to optimize for the number of calories that you eat per day, then you want to optimize, let's say, for a maximum of 1,000 calories, and then you are giving all the options that you have per day, like shawarma, falafel, and so forth, and you need to take into account whether if you just take one shawarma, then you won't be able even to reach that target. So we have our targets that we want to optimize for, and we want to find an algorithm that would be able to optimize. The bad news is that in many cases, we actually need to scan all the possibilities, all the combinations of all the foods that we can eat in a day, or all the items that we can steal from a house in a stealing session, and consider all of the options before we can determine what is the optimized solution. This is the brute force solution. Basically, it's taking the power set. The power set is the empty set, and then the all item set, and then all the combinations of the items that you can take. And then you take all the combinations. For example, you can steal the watch, the DVD player, the glasses, the jewelry, or you could steal nothing, or you could steal only the jewelry. And basically, once you take all the combinations, you decide which one is best optimized for stealing the items for the house. This is the power set. The power set is the set of all sets that you can come up when you have all the combinations of items. The question is then whether we can find a better solution. So not really, because in many cases it's only a specific combination. We can do some optimizations on the solution. But if we take, for example, the greedy algorithm just means that in each step we look at the possibilities and the options that we have, and we take the best one. We just, each time we're greedy, we are taking the most precious things that is available to us, and then once we have reached the limit of the weight, then we have finished. But now the question is, what is the best thing in each stage that we can have? So it's not for the stealer, it's not the thing that he sees immediately, it's the things with most value, okay? So that he can put in his sack. So if he sees 10 things in total in the house, then he would pick up the one with the most value, which is most valuable, and put it in his knapsack. Of course, assuming its weight is less than the maximum weight that he can put. The problem with greedy algorithms is that it's optimizing for a local maximum or local minimum, depending how we look at it, versus optimizing for the global maximum. So when we optimize for the local maximum, we take the next best step. For example, if we want to get to the top of the highest place in our surrounding, then our algorithm would be just walk either left or right, find the maximum place. If you can get higher, go higher. If you are getting lower, do not go over there and stop once you got to the highest place that you could. The problem, of course, is that if you turned left instead of right, maybe you would pick up a higher mountain. So this is the problem with local maximums, with the greedy algorithms, because in each step you take the best step, but it does not promise you that you would get to the global maximum, because maybe you shouldn't have taken this best step. Maybe you have a shawarma that has 99,997 calories, and instead of it, and then you would not be able to fit anything else, and you would have another food with 4 calories, so it would get 1001. So the greedy algorithm, while it's good, it's optimizing for the local maximum, which is also good, but it's not necessarily the global maximum. It could reach the global maximum, but it's optimizing for the local maximum, because you always look at the next best case. When we consider all the possibilities, then basically in the Knapsack problem, we have the limitation of the total weight of the handbag, which we denote with W, the weight. This would be the total weight that we are allowed to insert into our handbag. And then we take each item's value, let's say in dollars, and multiply it by either 0 or 1. If you multiply it by 0, then this means that this item you don't take into account, you don't put in the knapsack. If you put 1 and multiply it and do a sum, like a sigma sum, then this means that you would take this item. And the global optimization function means that the total weight of the knapsack bag should be equal or less than the W, the global weight of the handbag. So in this episode, we looked at what are optimization problems. Optimization problems are when you try to optimize a function and find the global maximum or global minimum. And the brute force way to do this would be to take the power set. The power set is the set of all sets, all of the combination of sets, subsets that you can take from a set of items, or the things that you can steal from a house. You can steal one thing, two things, everything or nothing. But you have then the limitation, the weight that you can put into the knapsack. So if you go with the greedy algorithm, then you would just pick up the best item. To pick up the best item, if you sort all the items, this would be O of n log n, because this is the usual sorting time. And when you sort them, you just pick up the best one, and then the next best one, and then the next best one. But as we said, the greedy algorithm is optimizing for the local maximum. So this does not promise us that we would reach the global maximum. So this was optimization, global maximum, local maximum, and the knapsack problem, and the greedy algorithm solution, and the brute force solution. I think this was interesting, and see you next time.